Today I'm going to talk about using machine learning and deep learning for information extraction. I'm working in machine learning for more than 6 years. I want to start my talk with daily life in the digital age, and I'm going to cover some topics including data, machine learning, neural network, deep learning. Then we are going to write some code about crime detection with CRAS, and we will conclude with addressing the question you may have. I think it's better we watch an animation. So, as you watch, a decade ago, we used to communicate with text and pay with cash. But today, we create so much more data in our daily lives. We pretty much wake up and go to sleep with our cell phones. We communicate online, work online, pay online, entertain ourselves online, and even date online. Our lives depend so much on a smartphone and the apps that we monitor our health, diet, sleep, and even track our period cycle with them. Based on a statistical published by Worldmeters, the population of the world is around 7.2 billion, with more than 2 billion of the population are connected by some apps on their cell phones. This new method of communication even creates an informal economy. So every day we create a data. Producing the data in our daily life causes a sophisticated and unpredictable environment. Big data can offer insights at a scale and leverage the best of machine intelligence. In contrast, thick data can help us rescue the context loss that come from making big data usable and leverage the best of human intelligence. And when you actually integrate the two, that's when things get really fun, because then not only you are no longer just working with data you've already collected, you also get to work with data that hasn't been collected. You get to ask questions about why. Why is this happening? By integrating big data and thick data, we not only improve our lives, but also we transformed how we consume communication. The data could be helpful and yet might be dangerous. Raw data, freedom, or fear. We'll learn about it. Besides, I think Joey Wave sang a song about it. Machine learning, an amazing word. This algorithm in 1962, Arthur Samuel, the father of machine learning, innovated a way of creating algorithm by prompting the machine to find pattern using data as an input. These algorithms could learn how to work using data rather than being instructed by hand. This algorithm can give us some output that we may not be able to create ourselves. Machine learning has three types of learning, including supervised, unsupervised, and semi-supervised learning. Oh, another magic word, neural network. Neural network is a branch of machine learning inspired by how the human brain works. Take data, train themselves to recognize the pattern of data, and predict the algorithm to find a set of similar data. The neural network is made of layers of neurons. They are the core process of the network. Each neural network has input, hidden, and output layers. The hidden layers are responsible for computation. So this kind of technique could allow us to fix a major problem. Wow! Another amazing word, deep learning. Recent advance in the neural network by Jeffrey Hinton in 2012 modeled a new network called deep learning. It has no theoretical limitation on what it can do. The more data and the more computation time you give it, the better it gets. Deep learning shows that computer can listen and understand. It's a single algorithm that can seem to do almost anything. Even to see, currently deep learning is the most useful and accurate method even compared to the native human understanding to confront issues the human race face, such as traffic jam, human rights, and the disaster such as coronavirus. Okay, we want to talk about extract information using ML and DL, crime detection. So I think I need another animation. Okay, I said the digital age changed lifestyle. I have to say it's also changed crimes. Based on FBI site, we have three classes of online crime: cybercrime, social offense, cyber-enabled fraud. These three classes have subclasses, which means each has a definition. We talk about life, daily life, so I want to use deep learning to extract one of social media crime that include trolling, online threat, disclosure of private sexual image without consent, online harassment, grooming, stalking online, virtual mobbing. Mm, I think a crime detection method including face recognition, pattern recognition, interactive clustering, text recognition, and classification. And also, I have to mention the library of DL. TensorFlow, Keras, and PyTorch is most popular library for deep learning, but I have some crush on Cross, so we use Cross. Okay. Crime detection as a classification problem using cross. So in we have same step for every classification problem. First of all, uh, we have to clarify problem statement and loading data require and clean the data, creating array and training, test, evaluate, and deploy the model. So we have to start. For problem statement, I think we need to clarify our data set and our definition as an our pattern. So, trolling definition means refer to practice of posting inappropriate or insensitive message online to upset or anger other people and to get a response from them. Actually, It's the best definition of trolling. So I'm using the hate speech and offensive language dataset. That data it's published it and it's labeled data. So let's start. First of all, in our dataset, we have three classes: hate speech, offensive language, neither. Hate speech tweets that by people judged as a hate speech or judged by offensive language or neither. So we have a three classes. Let's start. First of all, we import our module. We're using cross, so we need this library, import all of them. Then we set up our epochs. What's the epochs? Epochs. An epoch is defined as a single training iteration of batch and both forward and backward propagation. Neural network has a two kind of process: back and forward propagation. First of all, we setting our model, then embedding them. Embedding is a is is a function that converts a string to vector size, and maxlen absolutely is maximize length. It's a maximize length of our vectors. So we defined our output place in the start. We open our file. I said I'm using the offensive dataset. So I open it, use two columns named tweet and class. After that, train and test split. Train and test split is a I'm sorry. For training a model, we need first train and sure that our train is correct. So we split our data based on 82, and this code we're using 25% of data as a test data. Test data actually evaluate our trained data. Then tokenized word. Tokenized word is a one of the simplest step in our classification. Split the word as a semantic unit. Then we started to creating our model. We start by setting up the model. The second line of code called for the sequential constructor. We are using the sequential model because our network consists of a linear stack of layers. So we're using embedding and we're using pooling. What's pooling? It's common of periodically introduce pooling layer in between the conventional layers. This basically done to reduce a number of parameters and prevent overfitting. Overfitting is overfitting means our model doesn't efficient to learn new pattern from new data or improve their self. We have dense. It's a matrix vector multi prediction. So we're using Adam as optimizer, and we use binary cross entropy as a loss function, and our metric is accuracy. Accuracy means the true prediction of data. So we define our model, then tune model. We're using vocabulary size as an index and pad, pad sequential with 0. Padding refers to add extra layer of 0 across the vectors so that the output vector has the same size as the input. This is known as the same padding. So, a state of being 2. In class, like other machine learning method, we have to save our model and uh, run it for using in another data that's unseen from model. Okay, we save the model, and actually in run, I wish I could live coding, but as you know, in our country we have many challenge. For example, we have many challenge with the internet. I run the code in my laptop and I start to run it. You can see it. It's good working. After starting this code, we cross using TensorFlow and backend, but during 7 hours ago, I couldn't finish the process. But I hope it's finished and I could send the whole result of that model. Actually, it's finished, and for next step, it doesn't mean we know everything. Let's talk after talk.